Alright, so this is what question 6 looks like. Next one I'll be doing. Consider f of x equals x squared plus p over x. P is a constant. First portion says find the derivative, f prime of x. So, number 3, we saw this radical thing. If you have a radical, you always want to change it. You don't want to be working with those. Same thing here. You don't really want to be working with that either. So what you could do is you can change it. So x squared looks fine. We can use the power rule on that. So we'll leave it when we'll do the power rule on it later. So if you have something in the, you don't want anything in the denominator here, really. Definitely not the variable. So to move something out of the denominator, you just multiply it to the numerator and then make the exponent negative. So what that looks like is you keep the numerator, doesn't change at all, so p stays the same. Then you pull the x up and then you make its exponent negative. So it's x to the 1, so this would be x to the negative 1. So that's how that works. And then nothing changed here, it's still adding. So now you have something you can work with. You can use the power rule on both of them. So how the power rule works again, multiply the exponent to the coefficient. Coefficient here is 1. And then you keep the variable, nothing changes there, and then you subtract 1 off the exponent of the variable. So what that looks like. So you have your exponent, you multiply it to the coefficient. 2 times 1 is 2. Keep your variable. Then you subtract 1 from the exponent. 2 minus 1 is 1, so 2 times x to the 1, or just 2x. Here, same thing. So you have your exponent, negative 1, and you have your coefficient p. Negative 1 times p is negative p. Keep a variable, x, and then you subtract 1 off the exponent, so negative 1 minus 1 is negative 2. So that is the derivative. You can move this to the bottom since this is a negative. It would be p x over 2. It's not that, like both of these will work. So this form, and then you can change that to be that. Same thing. Okay, so that's the derivative. Then the second portion of the problem, part B, there's a minimum value of f of x when x equals negative 2. Find the value of p. Okay, so when you have a graph and you have minimum values and stuff, this is what it looks like. So, like, remember, this would be a maximum, and then if you had the graph like here, this would be a minimum. But one thing about these points is that if you want to draw a line, it has to be like that. Like, oh, yeah, that's like probably my best shot at a horizontal line. There's no way to have it slanted. So what that means is the slope has to be 0. If it's horizontal, all horizontal lines have a slope of 0. So the derivative 0. So basically, if there's a question like, there's a minimum, there's a maximum, set the derivative equal to 0. So like this is the derivative, we're going to set it equal to 0 in a second. Why? Because when you draw the graph out, it shows that the derivative, the slope is going to be 0. The tangent line is going to be 0. So how that's going to work is put 0 equals 2x, and then I guess we can change it for this one if you guys want to see how that works. Minus p x over 2. And the derivative works at a single point. So they tell you the point is here. What would the x coordinate of the point is? Negative 2. So you plug in the negative 2. Because like remember, it was always slope. You need 2 points. Like when you derive, you're finding the slope at a single point. So that's what we're doing here. So this is going to work. 0 equals 2 times negative 2 minus p over negative 2 squared, which is going to be 4. So it's going to be negative 4 minus p over 4 equals 0. this is just algebra from here, no more calculus. Negative p over 4 is going to equal negative 4. P equals negative 16. Yeah, p equals negative 16. Yeah, so that's the answer to the question. So just remember, if it is minimum value or maximum value, to set the derivative equal to 0.